Thank you for coming back at our channel, The Physics Mindset, the only channel to give you technical information and engineering concepts in electrical installation, electronic installation, and solar installations. Okay, electronic, those are repairs. We shall do the repairs in electronics. Okay, now on this channel, please subscribe, like, and click the notification bell for more engineering and technical tutorials. You will not miss anything we are bringing for you. Now today we are going to look at one of the fundamental concepts in electrical engineering. Okay, without this concept, which is called an electric charge, this is one of the concepts in engineering, in electrical engineering. Without knowing this, it will be hard for someone to fully understand what electric current is, or to fully understand what the voltage is and what the resistance is. And these are the concepts we are going to look at in electrical engineering. Now, without knowing what electric charge is, it will be hard for you to understand these concepts. Now, let us jump into today's lessons. Electric charge. What is electric charge? Here we are saying an electric charge is a basic property of matter. Listen very well. It is a basic property of matter that causes electrical force. Not these technical terms inside here. That causes electrical force between objects. Between objects. Now, let me give you. Check this. This is an object. This is an object. If you can see them with your naked eyes, it means they are occupying space. And anything occupying space is called matter. Matter is anything which occupies space. Now these are myself. I occupy space. I'm a matter, because once you hear matter, just know they are also what? An atoms inside. The smallest particle in a matter, it is called an atom, meaning are made of millions and millions of atoms. The same thing happens here. These things also are made of atom. Okay, now they are saying it is an electric charge. These are the terms we are going to use in electrical engineering. Electric charge, electric current, voltage, resistance. Okay, now if they are saying an electric charge is a basic property of matter that causes electrical forces between objects. Now, these are the objects. In between here, if this is a positive and this is a negative, let's assume to be positive and negative. Now, in between here, the reaction which will happen in between objects is called electric charge. And this is what they are telling us. Property of matter that causes electrical force between objects. Electrical force, because we are dealing in electricity. And this is the fundamental of electricity. Without this fundamental concept, you'll be limited in some electrical concepts. Now, let's say an example about this electrical force. What do they mean by this electrical force? They say it has a property of matter that causes electrical force. Now, let's assume that we have a positive and a positive. A positive and a positive. What do we get? Remember the principle. Like poles, unlike poles. Okay? Now, these are like. They look alike. Meaning, like poles repel. Like poles repel. because it is a positive and positive, so repulsion will occur in that event. And if it is a negative and a negative, what happens? Negative plus a negative, also repulsion will occur in that event. Also here we shall have repulsion. Now, what if we get a positive and a negative? Wow, a positive and a negative, positive, negative, positive and a negative. Negative is black, positive is red. What happens? If you bring them together, electrical force between objects, if you bring them together, in between here, the force which will be in between here is what we refer to electric charge. There will be some charges. You might even see sparks because of that charge, that attraction. Meaning, here, a positive and a negative, we shall have a big attraction. Attraction will occur. In between, attraction will occur. And this principle, we can't forget this principle. Never forget that like poles repel. Unlike poles, they don't look the same. They attract. Like pole repel, unlike pole attract. That's the principle. Never forget that principle. Okay? Because it is going to help us a lot when we come into a lot of concepts in engineering. Now, since we have seen electric charge, and this definition drives us to it saying, it's like they are saying, it is the reason why objects attract and repel each other. That is electric charge, and we shall see an attraction in objects or repulsion in objects. Now, since we know that we are talking about electricity, and we know we are going to talk about the cables, power, resistance, current, voltages. Okay? All without the concept of electric charge, we shall not understand them well. And all the things, the cable, like this cable, it has two cables, a brown and blue. Meaning a brown is the live, blue we shall reach at the color code, then I will show you the color codes. Now today we are on electric charge. This cable is made up of atom. It is a matter, it occupies space. This is space. There are very many atoms which were combined to make this cable. Okay? And these atoms, each atom has 3 particles. Which 3 particles we are seeing? Okay, let's look atoms. Let's look back small or about the atoms. They have 3 particles. One is a proton. Another one is an electron. Another one is a neutron. These are the 3 particles in an atom. Remember, there are very many atoms in a cable or in anything which occupies space. Now, in a cable, we are talking about cables because we are in electrical. Okay? If we are in biology and we are talking about human behaviors, our body, we shall also talk about the atoms inside our bodies, the cells. Okay? Now, we are on electric charge. Since atoms have protons, electrons, neutrons, protons carry positive charge. Protons carry a positive charge. And electrons carry, you see where we have got the word charge, and we are studying about electric charge, and we have seen now a positive charge from a proton. Remember, an atom has a structure like this, let's say, and here we have protons in the cell, which are together with neutron. Then on the outer shell, we have electrons. Okay, now inside the nucleus we found a proton which is carrying a positive charge, and we have a neutron, these neutrons, which are carrying no charge. But on the outer shell we have electrons which are carrying a negative charge, meaning electrons carry negative charge. And this is, we are seeing where electric charge is coming from. We have seen the positive charge and a negative charge on an atom. Now, a neutron is inside a nucleus. They are in one place. They don't move. Only electrons are the one which move. When voltage is applied, electron move from one place to another. And once electron move from one place to another, it is when we experience an electric charge or electricity. You see how we are going to know electric current? When electrons move, when you apply voltage on an electron, this is the voltage. The voltage push electrons, and once the electron move in a cable, there will be an electricity moving, because the definition of electricity is a movement of electrons in a conductor. All right, now electron will move, but protons and neutrons are in a nucleus, whereby they will not move. They are in one place. Neutron carry no charge. Carry no charge. Neutron carry no charge. Proton carry a positive charge. Electrons carry negative charge. Okay, never forget this. Okay, because we are going to use these things in your field, in your time when you're working. You'll have to master these things to know electrical circuits, electronic circuits. You will know that there is some negative and positive, or there is a neutron, but mostly we use these two types. Okay, now in an atom, the number of protons are equals to the number of electrons. Okay, the moment you apply voltage in a cable, these atoms inside will start moving. When you apply voltage in a cable, protons, electrons inside the cable will start moving from one point to another. But protons will not move. Only electrons are the one which move from one place to another. While in their movement, they causes an electricity to appear in a cable. Okay? Now, since we have this information, so let us try to see what are the types of electric charge. What are the types of electric charge? Okay, now let us look at the types of electric charge. What are the types of electric charge? Types of charge. Okay, we want to look at the types of electric charge. We have mainly two types of electric charge. Master these words, listen them well, because you're gonna use them in your fields. Electric charge has two types. One is a negative charge. And another one is a positive charge with a symbol plus. These are the types of electric charge. I know you have been knowing these terms, but you don't know what are they. These are electric charges, okay, on an object or between an object. Let's say a battery. An example is the battery. Let's put here our battery. It has two terminals, a positive and a negative. Now, in between here, there are some chemical reactions inside the battery. Okay, there is a rod, but there is a chemical reaction. Now, in between, when you apply your bulb, connect it on the battery, the movement of current. Remember, we said when you talk about charge which is in one place is static electricity. It's a type of electricity which is called static electricity. Remember, in electricity, we said we have two types. We have static electricity and current electricity. Now, this charge which is in one place is in the types of static. Okay. Now, people say movement of electrons from the battery, current starts from which side? I see that electrons are the one which move. Meaning, movement of electron starts in the side of a negative, because electrons carry a negative charge. Those are electrons, not positive charge. Positive charge are in nucleus. They are in one place. They don't move. Meaning, on a battery, in a negative terminal is the useful terminal, is the dangerous terminal. Negative, because it carries electrons, electric charges. Meaning, power will move from this side, a negative terminal, to positive. But I don't know why we say power move from positive to negative. If we see in electrical power move from the positive part to the negative. But in DC, static, power move from electrons to positive. Okay? You should know the difference. Now, as we have seen down the types of electric charge, we shall see that an object can be, let's say this is our object. An object can gain electric charge or lose electric charge. I think let us see how an object can be charged. How an object can be charged using these negative charges and positive charges. An object can gain electric charge or electric charge. Let's say electric charge, either positive or negative, by losing electrons or gaining electrons. If it has electron, let's say, let me use their sign. If it has positive, 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 positive. Now, this object, this is an object. This object has more of positive charges. These are positive charges. It means this object has lost electrons and it is having more protons on its surface. And remember, in static, these charges remain in one place, meaning this is a static type of electricity. Okay? Now, electrons have moved away from this. This object has lost electrons. And once this object gains electrons, let's say, again, once this object gains electrons, what happens? Once it gains electrons, okay, it means this object has gained electrons and has lost the protons. And that is the principle of repulsion and attraction, that unlike poles attract and like poles repel. The object has lost the protons and has gained electrons. And this is how an object can have electric charges. It is either it has lost electrons and protons have occupied the object. That is, an object has lost. An object to have electric charge, it is two-sided, either a loss in electrons or a gain in electrons. Once it gains electrons, it means protons or positive charges have moved away. And once it loses electrons, it means positive charges have occupied the space. And it is either charged in a negative charge or a positive charge. And that is how objects gain electric charge. Or that is how objects charge. Okay, now, without wasting time, I'm going to give you a simple mathematical formula which we can use when any question which is designed concerning electric charge. Whenever you see electric charge, let me give you the formula which you can use in your work, wherever, in a question, any technical question, anything concerning charge, use this formula. Very simple formula, and it will work for you very well. Okay? Now, this formula is charge. If they ask you anything about charge, that find charge, electric charge, let's give it a symbol of Q, will be equals to the time taken for current to move. Say 2, that is it. Time taken for current to move, meaning the time which will be taken for the current to move per second. And electric charge is measured in coulomb, which is represented with letter C, coulomb. Electric charge is measured in coulombs. That is the SI unit of an electric charge. And this is the formula you will use in an electric charge. Okay? Let me try to use red. Now, let's do a small work. assuming we have current of 5 amps, 5 amperes flowing in a conductor for 10 seconds. Now, if they say find the electric charge, in a circuit. If this is the question, how can you come up with the formula? The formula is here. As I've told you, this is the best formula you will always use when you're finding electric charge. Any question coming with electric charge, just say electric charge, which is represented by Q, whereby current times time, where this is current, which is measured in amperes. 5 times time is measured in seconds. The current 5 amps flowing in the conductor for 10 seconds in an electric charge in a circuit. Find the electric charge in the circuit. 5 times the time taken, which is 10 seconds. How much do we get? This is electric charge. You know, I didn't. Q represent electric charge, and I is the current. Then T is the time, measured in seconds. Current is measured in amps. Electric charge is measured in coulomb. Now, what is the current times time? 5 times 10. What do we get? We get 50. 50 what? 50 coulombs, because electric charge measured in coulombs. 50 C. Or you can write coulomb. 50 coulombs, which is C. Or you write 50 C, which represent a electric charge. Now, 50 coulombs are the electric charges which flow in an electric circuit holding a 5 amps in 10 seconds. Okay? And this is the simple formula, this simple question. Whenever they ask you about electric charge will look at current flowing in a given period of time. Okay? Since we have we know that if you're finding electric charge, meaning there must be an electrons moving. And in the next video is what we are going to see about electric current. How these electrons are caused when they move to create current flow. And in the next video, that is the one we are going to talk about, electric current, talking about how does these charges, when an electric charge move to create electric current. Thank you for watching. I will see you in the next video. Don't hesitate to miss an electric current as our next topic, because we are following step by step so that we don't miss. We are understanding everything in electrical engineering, electronics, and solar engineering. These things will help you into tomorrow's lifetime when you're doing some projects in electronics. Without knowing electric charge, you can't know, because you see how electric charge is driving us. In the next video, what we are going to see about electric current, because we have found out that when a charge moves when there is a charge, when a charge is applied, electrons will move. And once electron move, current must be there, because a voltage is the pressure which pushes current. And once the current move, meaning we shall be having an electric charge and the time taken. Let's try to look in the next video about electric charge. Thank you. See you there. Subscribe, like and share with your friends, students who are doing electrical or electronics, and your family members. Whoever wants to join electrical engineering, it's free on the physics mindset. Thank you. See you there.